Okay, so here we have a trigonometric limit. Now the first thing that we'll probably try is to switch cotangent and cosecant in terms of sine and cosine. And maybe that'll allow us to simplify something. Okay, so I know that cotangent is equal to cosine over sine, so let me do that. So let me rewrite it. Cosine over sine. Okay, so that's what cotangent is, and cosecant is 1 over sine. Okay, and if I do my tortilla here, I would get that this is equal to the limit as x approaches pi over 2 of sine x cosine x over sine x. And these guys cancel, and if I now plug in pi over 2 here, I would get that the limit is equal to 0. Okay, so here we have a limit as x goes to infinity. Now remember, the usual trick that we use is we look at all of the terms and figure out what the highest power is. And so here the highest power is 1, so that means that we're going to divide the numerator and the denominator by x to the highest power. Okay, so I'm going to divide, I'm just going to rewrite everything again. I'm going to divide everything by x, because that's what the highest power is. And then I'm going to simplify. So notice here the x's cancel. Here the x's cancel. And so what I'm left with is the limit as x goes to infinity of 3 plus 5 over x over 1 minus 4 over x. Okay, now these guys, as x goes to infinity, this guy is going to go to 0, and this guy is also going to go to 0, because they're getting smaller and smaller and smaller, so the only thing that's left over is 3 over 1, or 3. Okay, so we're going to approach this problem how we usually approach infinite limit problems. So I'm just going to rewrite it. And remember, you look for the highest power. Here the highest power is 2. So we're going to divide numerator and denominator by x to the highest power. Okay, so we're going to divide by x squared. And we're going to simplify, and here this x cancels with one of these. These both x squareds cancel. And now if I rewrite this, I would get the limit as x goes to infinity of 3 plus 20 over x over 4 plus 9 over x squared. Okay, so these guys are going to 0, getting smaller and smaller and smaller, and so what I have left is simply 3 over 4. Okay, now this time we're going to negative infinity. But we still approach the problem the same way. We're still going to divide by x to the highest power. So now this time the highest power is 3. So I'm going to divide by x to the third. Okay, now I'm going to simplify. So here these two cancel with two of these. This one stays the same. Here I get just 1. These two cancel with 1. And this one stays the same. Okay, so now if I rewrite it, I would have the limit as x goes to negative infinity of 1 over x plus 2 over x cubed over 1 plus 1 over x minus 1 over x cubed. And this time, there's lots of these guys that go to 0. This one goes to 0, this one goes to 0, 0, 0. So what I have is simply 0 over 1, which is just equal to 0. And if you look at the very beginning, you could notice that the degree on the denominator is bigger than the numerator. And well, that means that this term is going to overcome the entire fraction, and the whole thing is going to get smaller and smaller and smaller. So that's why it went to 0.